partners. And we've got Professor Shai Efrati, who is director of the Segal Center of Hyperbaric Medicine and Research. And all of them, of course, have much greater bios than I'm going to be able to describe here for this session. So thank you all for being with us. I appreciate it. Professor, I'd like to start with you. Your work on RNA has earned you a Nobel Prize, but also has been instrumental, transformational for biochemistry. So explain to us how sequencing is changing medicine, but also will change our lives.
So people here are aware of the impact of RNA from the vaccines that were introduced in the past couple of years. What they may not know is that the impact is potentially far greater. The vaccines were limited by the capacity to deliver the RNA molecules to human cells. That is a problem which in the last couple of years we have solved. It means that on the basis of the nucleic acid sequence of a virus, or indeed the sequence of the human genome, we can now immediately design medicines, deliver them to human cells, and cure a vast array of human disease that was not accessible in the past. It includes, of course, the possibility of personalized medicine, since the nucleic acid sequence will differ in subtle ways from one individual to another. That, too, can be realized in this respect.
One of the fields that many people are looking to RNA technology to is actually dealing with cancer and treating cancer, and there has been much work on that, and that importance of being able to have those nuanced differences depending on genes. Can you tell us a bit more about that and how you see that?
So cancer arises from mutation, so it arises from a change in the nucleotide sequence. We can identify that change, we can design an RNA molecule that will target that difference and solve the problem.
Dr. Kahel, I'd like to ask you about how, again, sequencing will change medicine, but also it requires investment and it requires further work. Can you tell us your take on it?
Sure. Look, sequencing's already kind of changed everything. I think people don't really think about it that way. The first sequence was done in, I think, 2001. Maybe it cost about $3 billion US, and now probably get a full sequence and analysis is somewhere between 200 to a couple thousand. But if you think about pre-cancer screening, I mean, you hear about BRCA genes, BRCA1 or 2, which are associated with, ovarian, breast, and prostate cancer. Just the impact on diagnostics is already being seen clinically.
I'm really sorry to interrupt you. Can I ask you to just pull the mic up a little bit? Thank you.
I'm usually pretty loud, so. But my point is, sequencing's already changed everything. We're 20 years into the first sequence, and just like the internet, it took about 20 years to get to that inflection point. Right now, we can sequence and identify where the problems are. The more data we generate, the closer we're going to be to personalizing medicine. But at the very least, just knowing your sequence allows you to prevent disease. And I think we can probably talk about some of the newer treatments that are coming out to solve, actual diseases, but just prevention alone has been a hugely transformative impact.
And Professor Efrati, I'd like to ask you the same question. I mean, everything from the impact on individualized medicine to also looking towards the future, how this can transform our societies.
I will refer first for DNA and epigenetic, which people speak a lot. Okay, just to give perspective, because I know that people in that room are not coming from biology, most of the people over here. So DNA, it's like a textbook that you have. And at each point of your life, you can read different chapters. So when we are young, we are reading a specific chapter and look at our physiology when we are young. And when we are old, we are reading another chapter on the same textbook, okay? And look at the physiology over there. The insight of that makes us say, I don't want to read the last chapter. I want to read the first chapter. So what are the triggers that can make me stay on the first chapter? And we can do that today. Okay, not by invasive procedure. We have a way that we can do that. And this is the epigenetic. So we have the DNA, but we can choose the chapter that we can read.
So the chapters, if we take that analogy further, is one that people are really thinking about when it comes to personalized medicine. How do you see the access to personalized medicine on a larger scale? Is this something that we're going to see scaled up in the near future?
So there is no doubt that will occur, and Dr. Cahill has already mentioned the ease with which the entire genome sequence of an individual may be determined. And now, referring to the comment about epigenetics from Professor Efrati, the read of the genetic sequence will include also those modifications which constitute the epigenetics that marks the genome in respect not only to heredity, but also state of the individual.
And and then that, of course, takes us to precision medicine. So, Dr. Cahill, if I can ask you about how precision medicine will change healthcare and the impact it will have, again, on health administrators.
Sure. I would just say it already is changing healthcare. I mean, another panel, I use this example with, a metastatic melanoma, which, is one of the most fatal diseases upon diagnosis. And in 2011, before kind of sequencing and Keytruda had come out, about 5% of people after diagnosis lived more than 5 years. By 2017, over 55% of those people were still alive. And so that's personalized medicine, right there. I mean, that's a real impact. And, as both of these scientists mentioned, is science is kind of like the Lernian Hydra in the sense that every time you cut off a head, you learn 2 new things. And so it starts with the DNA sequence, and then the epigenetic sequence. And now the next thing that people are looking at is actually the configuration of the DNA within the nucleus seems to make a difference. And so it's always a new thing that we're going to discover, hence your point of investment. We had CRISPR 1.0, then we have base editing, which is CRISPR 2.0. And now we have prime editing, which is really like the holy grail in CRISPR 3.0. And so it kind of takes 1, 2, or 3 generations to get to a gene editing or technology, or any type of technology that really can be transformative.
And so if we look at, again, Professor Efrati, taking your textbook analogy, if we look at the chapter of older age, and as more and more societies are aging and we're living longer, how does this then affect age-related decline?
So we are in a governmental summit, okay? And as a government, especially in the UAE, you're thinking, what is our next challenge? So our next and current challenge is what is exactly the age-related cognitive and functional decline. Just for perspective, today in China, not in China, in Japan, there are more diapers that are being sold for older individuals than for babies. In Europe, we're going to be there in 2 to 4 years, the same in the US. I don't know the data with regard to the UAE. And since we don't know it, that means that this hasn't been approached as a problem yet that need to be faced. So we are elongating life, but the most important thing is not lifespan, it's health span. And once somebody has dementia, somebody have Alzheimer, especially here in the UAE, where people, part of the culture is not sending back them to a nursing home. Okay, here you keep them with you at home, which is amazing thing. When somebody dementia, somebody Alzheimer, it's like a stone that is coming down to the sea, and everything that is tied to it is going that with it. So if you ask me what is the most important, challenging, economically, socially, personally basic, I don't want to be in diapers, okay? And I don't want that my close friends will be in diapers, my close family, because that will take me down. So I think that the challenge is exactly that, the age-related cognitive and functional decline. And I think that if we will face that appropriately, we can generate a dementia or Alzheimer-free community, or at least narrow the period where we are dependent. And we can use the science that we have today to achieve it.
Professor Romberg, are we there?
In fact, I can speak to that directly. So I mentioned in my first remark the capacity today to deliver an RNA molecule that is therapeutic, even curative for disease. This is a new capability, and it exists at this time for Alzheimer's disease. We are in the process of making the first such molecule, and in collaboration with a group at the Mass General Hospital of Harvard in Boston, I expect that within a very short period of time, Alzheimer's will no longer be a scourge of humanity.
That is an incredible milestone for humanity to be able to reach. What would it take to make sure that that's scaled up? Is it going to be through vaccine? Is it going to be through drugs that are self-administered?
The chief obstacle is regulatory. These medicines are available now for respiratory disease. Take the case of SARS-CoV-2. We have such a medicine now which is 99.9% effective, which will cure the disease. This is not a vaccine. It is not injected. It is stable. It can be transported. It is self-administered. All that stands between that and its availability to the population are regulatory hurdles. When the next pandemic strikes, which could be as soon as tomorrow, we have the capacity to determine the sequence of the new virus and make that medicine overnight and protect the entire population. Again, all that stands between that capability and its implementation is the slow pace, the bureaucracy, the risk-averse nature of regulatory agencies. It is a broken system, and it needs to be fixed.
Now, do you see it as broken in the United States or on a global level?
It is true in every nation of the world. There is no exception to this problem. And the solution is so straightforward, but again, what we face is an intractable bureaucracy.
And without the regulation and without the authorization, of course, then the funding also can't follow. So, Dr. Cahill, how would you see it best to tackle that, the regulatory side? Putting you on the spot here.
I think when you're dealing with regulators, for our work with the U.S. government and some of the governments here during the COVID pandemic, is try to remove yourself from try to remove any financial conflict when you're dealing with the government, and try to be as transparent as possible with them about the pros and cons. Part of the issue is advocacy. I mean, if you look at Vertex and cystic fibrosis, if you have enough capital coming from enough patients, you can change things. But again, what has to be shown is how can the government benefit? How can the country benefit? I mean, if we just, I'm going to jump on a little bit of a tangent because I think it's important. If we were to say what we did for Warp Speed, what we did for COVID, if we just did that, for obesity, that would probably save many more lives than were lost with COVID. And now again, I have no financial conflict here, but these new GLP-1 drugs really transform outcomes, and they may be a bridge to a new therapy. I mean, how many people here have heard of Ozempic or Wegovy or any of these drugs? And some people. I mean, these drugs it's the best-selling drug in the U.S. right now. It's been around for 20 years as a diabetes drug. It's generally safe. It's actually the receptors I studied with Bob at Duke, their GPCR. So they're safe. And I mean, the weight loss on these drugs is 15 to 20% in a year, which is completely transformative. And if the governments were just to reinforce that, the argument would be when you increase lifespan, you don't decrease costs, because the last year of life is always most expensive. But when you increase lifespan, you increase the human capital that actually benefits the country and benefits companies. And that's the argument to be made to CEOs and to governments, is that the more people are able to go to work and the better quality work product they're able to make is better for the country and society. And that's kind of the argument to make to the regulators and the insurance companies.
But there's still, Professor Frattini, there's still a concern that actually regulators say we're the last line of defense. It will come on us if we approve or disapprove a certain drug. How would you respond to that?
I don't want to refer to the regulatory part. I will refer to the scientific research part, which is quite amazing what's happening today. I think that the number one bottleneck to making a progress for us as Homo sapiens is where the mind power or the brain power is going. And when I'm saying brain power, I'm speaking about the young individuals who are looking now to do a PhD research or things like that, and they want to dedicate their career to something, okay? An amazing thing happened to us, at least in my university, during the last 5 years. There are young people, brilliant people, who are coming to me and saying, "Dear Professor Efrati, I want to dedicate my career to aging." Now, this is a 25-year-old person. He's dedicating his career to person. And this is the brain power. The brain of this young individual is the most important thing that we have as a society. And once we are moving this spotlight to the age-related cognitive functional decline, then we can break everything. Break everything as Homo sapiens. We went to the moon, we break the stars, we can break a lot of things. The regulatory will follow. The regulatory, it's you. You will solve that, okay? But we need to bring, in my part of the field, okay, we need to bring as many as possible intervention to reach a point where you as a regulator need to prove that. So that's bottleneck. It's been open in last year, so I'm quite optimistic about it.
I mean, the free market does solve things. I mean, when people couldn't get access to semaglutide, they were just compounding it themselves. I mean, so then the regulator started opening up access to it.
But I wanted to ask you also about how life science discoveries are allowing more and more information sharing, discovery sharing between fields. Because again, for us lay people, we always think it's separate. If we're talking about Alzheimer's, we often don't think, okay, actually the discoveries that are being made are also going to impact other types of diseases. So how is there more cross-field knowledge sharing, data sharing?
The world of science has changed. So when I was a student, when my colleagues here were students, there were separate disciplines of physics, chemistry, biology, medicine. Today there is only a single scientific discipline that transcends them all. The boundaries have blurred, and physicists study biology, biologists rely on physics. That kind of separation no longer exists.
Dr. Calhill, did you want to comment on that, the sharing and the knowledge sharing between fields?
Yeah, as I had mentioned, every time you discover something new or you think you solve something, kind of two new problems occur or two new discoveries occur. Right. And so science has become, has evolved, as Roger was saying, from a field where you have kind of a king, an academic king, to one where it's not possible to do everything. You have to work with other people. And so you really start collaborating across specialties because there's too much to know.
Mm-hmm. Okay, sorry.
I would pick up on the comment that Professor Efrati made. Indeed, the importance of encouraging and enabling young people to study science, especially fundamental science, cannot be overestimated. Sadly, it has become more difficult today than it was in the past. The number of barriers greatly increased, and barriers that are far higher. In my day, that of my colleagues here, a young person could pursue a career in science and be supported in a meaningful way. Unfortunately, that is no longer the case. A young person wishing to pursue a career in science will require at least another decade of preparation, and when they finally reach the point where they might be employed in a meaningful, in a sufficient way to pursue that career, the openings, the job openings, what have you, the opportunities no longer exist.
Why is that?
There are a number of reasons for that, but fundamentally it comes back to government. It is the responsibility and the role of government to make the opportunity available to young people to do work which is not going to lead to riches of a conventional nature, but will lead to riches, to a form of knowledge which is even more rewarding.
Yeah.
I would like to say something about that, because the student and the young brains are the most important thing, and opening certain arena to people who are coming from completely different field is highly important. That's how innovation are made. I see that people are holding phones in their hands, okay, and the company, and they're all texting, okay? A couple of years ago, the phone was for speaking. So the ability of us to make a process is also related to us. When I'm saying us, I'm saying as a teaching professor in the university. I always teach my student that the number one limitation for them to making progress is the knowledge that they gain from me at this moment.
Right.
Because this knowledge became their rate limiting factor because they take it for granted. And the worst thing that happened to us as teaching or somebody who is a bit older is the things that I teach become my main limitation to making a progress. So because I don't want to say that I was mistaken, okay? I teach somebody wrong. So the most important thing is to create an environment, and we should invest thought about it, that embrace the failure, okay? Embrace the change. Never say, I don't believe in that, I don't believe in that. Say, I want to check that, I want to evaluate that. And once we are putting a spotlight about something and you generate an environment that embrace and celebrate failures, like I'm doing in my lab. When somebody failed, we are doing a big celebration. I say, wow, this is great. Our theory was failed. We can do something else. By doing that, we can make a real progress. And it can come through medications, through interventions, through changing environment. The focus should be on a problem that is important to all of us, and embracing failure, embracing the change, giving push to the young people to move forward as fast as possible. That's the way we should do it.
And it's what you do with that failure.
I'm trying.
Yeah.
I'm trying.
So we're unfortunately out of time on the panel, but there is a question that I wanted to ask each of you. So I'm going to ask you to answer very briefly, which is, for the immediate future, for 2023, what sorts of scientific advancements do you see on the brink of perhaps moving the needle? What are you keeping your eye on when it comes to scientific advancement? In a minute.
Look, it's very simple. I always say that the only thing I'm sure of in regard to predictions of the future is that they are wrong.
What are you keeping your eyes on, Dr. Kahel?
I think in the next 10 years, I'll say that. I think that gene editing will become a real treatment modality in patients.
In my perspective, the goal that neurogenesis, generation of new neurons in the brain, will be an acceptable concept that people take for granted and only ask how they can generate more neurons with that intervention as compared to the next intervention.
That's great. Well, thank you very much. Thank you for sharing your wisdom and insights with us. And please, a round of applause to our panel. Thank you.